The unit conversions, the dimensional analysis is part of the unit conversions. However, you can, this one will due, everything here will be due between this 27 and 29 will be due next week, Friday. All right, so you can space your time off. Even now, for today's lesson, the main part of today's lesson is going to be on scientific notation and also a brief mention about the mole. Now, let me quickly go over scientific notation. This is just about 4 slides. I don't think you have very few activities here, so that way you can practice with this. But before you do that, I want to share my pen. I'm going to share a question here on scientific notation. Now the question is, why scientific notation? Now if you look at what we have here on this model, it says scientific notation is simply a way that scientists write very large or very small numbers in such a way as to make it readable or easy to work with. When we're doing what's called mole calculations, you're going to encounter very small numbers and also very large numbers. So it will be very tedious having to type in all the zeros, all the digits in a calculator. And because of that, to make it easier, we're going to be using a lot of scientific notation. Going to write most of them in scientific notation. So it makes it easy. So when you write scientific notation, you always use a number between 1 and 10 as a coefficient. And then you multiply that by a power of 10. What do we mean by that? Like the example I have here. I have the first one here is I have a very small number. This is a very small number here. Okay? And then this is a very large number. Now you could see that in both cases you have a lot of zeros, which are simply placeholders. If you're going to put it in your calculator, you might miss out 1 or 2 zeros if you have to start typing each one. So in scientific notation, we're going to write this in scientific notation to make it easier to see or to use. Now, basically what you have to remember is that when you have a very small number, you're going to move the decimal point. In this case, the first one, the decimal point, you're going to move the decimal point to the right. And as you're moving it, you're going to count the number of spaces that you moved the decimal point. And now the question is, where do you know where to stop? That is where that digits comes in. Your coefficient has to be less than 10, which means that I can't move this decimal point to this spot right here. I can't move it there. I can't have 12.3 because that will violate the rule. The rule is that the coefficient has to be less than 10. So the only way this can be less than 10, if I move the decimal point to after the 1, before I now have my 2, 3. So this will be my coefficient. So the coefficient has to be less than 10 in order to satisfy the rule of scientific notation. So now let's look at, if I want to do this, if I want to write this number in scientific notation, I'm going to simply move the decimal point. I'll start moving the decimal point to the left, to the right by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So which means that my coefficient is going to be 1.23. And then I'm going to multiply it by the power of 10. Base 10 times 10 to the 10th power. The 10 power simply tells me the number of times that I moved the decimal. I'm going to use a negative sign there because it indicates that if I want to write this number in scientific notation, if I want to write it in this format, I have to move the decimal point 10 places to the left. If you remember the number sign, in the number sign, you have negative on the left, and then on the right you have positive. So if you have this here, it means that if I'm writing this, I'll simply move that decimal point by counting 10 places to the left in order to get me back the original number. Does that make sense?
Yeah.
Okay. Good. So in this case, in this one right here, in the larger number, we're going to assume an imaginary decimal point at the end of the zeros. So we're going to move this decimal point to the left for large number such that the coefficient will be less than 10. For me to do that, I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You could see that that is a place that will give me a coefficient that's less than 10. So this will be my coefficient, 1.23 times 10. How many power is that? How many times I moved it? Which is 11. So which means that if I want to write this number in the standard notation, which is what I have here, I have to count 11 places to the left. Sorry, to the right, because of the number sign. To the right, I have to move that decimal point 11 places to the right in order to get me my original number. That's simply what scientific notation it's all about. Now, I want to quickly add this, especially when you're using scientific notation in calculation, which we're going to be using in calculating more. Always put it in parentheses if it's in the denominator. Or what do I mean by that? Let's say I want to divide. I'm asked to divide. Let's say I'm asked to divide this number. I'm asked to divide 1. Okay. I'm just asked to divide 1.23 times 10 raised to the power negative 10. I'm asked to divide it by 1.23 times 10 raised to the power 11. For me to put this in a calculator, I must make sure I put this denominator in parentheses. If you don't do it, your answer will most times be wrong. So I will encourage you to always remember to put the denominator, especially if you have more than one entry. Put it in parentheses when you're putting it in your calculator so that you can have the correct answer. That's basically what scientific notation it's all about. Okay? Now, on the other part of this lesson, it kind of introduces you to the mole. So here we are told how big is a mole. This lesson simply gives you an understanding of the size of a mole. Okay? Now you have to remember, in all of this, one thing you have to remember, the main thing you have to remember in this module is that 1 mole is equal to the Avogadro's number. And what's the Avogadro's number? That is that 6.022 times 10 raised to the power 23. That is 1 mole. Okay? So That is basically what this single module is. And then this video, which is about 4 minutes or 3 minutes, simply kind of explain to you in terms of visually how big or how large a mole is. And that's all you have to do on this. The takeaway here would be mainly that 1 mole is equal to that. And also the fact that a mole is simply a unit of measurement. Just like you have grams, kilograms, liters, the same thing you have mole. So scientists use mole to measure the quantity or the amount of a substance that is taking part in a chemical reaction. Now, when you click on next, which is the next activity under this, it's simply a discussion question where you pick one of these 3 questions. You don't have to answer all the 3. Just pick one question. It could be the first one. Say the mole is a really helpful way to count really small things. Are there other methods we use to help us count? Do we have a number that helps us group really large things? You're going to copy that. You're going to click on this reply button, copy that, paste it, highlight it red, or change the font color to red, and then you type in your response. Okay? Based on the information you have, just type in your response and then post it. And then you go ahead and respond to one of your classmates' post. It could be in form of question, asking for clarification, or it could be adding some more information to what that person posted, or something that clarifies it. Okay? So fortunately, there's already one person that posted, so which means that you're no longer exempt. So if you were the first person to post, you would have been exempt from replying to some other person's post. All right? So just reply to anyone's post, and you will be fine. You'll be done. Okay? And that is all I want you guys to concentrate on today. This, and then next class period, you don't have to start any of these February 2nd now. We'll just wait till Tuesday next week to begin that.